Okay, so we're given that triangle PQR is congruent to triangle STW, and we're asked to identify all pairs of corresponding congruent parts. Okay, well, it might help to actually draw the triangles. Right, so PQR is congruent to STW, and since we're at liberty to draw the triangles however we want, we might as well draw them so that it looks like their corresponding parts are in the same positions. Okay, so I'm actually going to write over in a different color just to highlight those corresponding parts. Okay, so we can say that angle P is congruent to angle S, that angle Q is congruent to angle T, and angle R is congruent to angle W. Okay, the angles are the easy ones. Okay, so now when we want to identify the sides, we want to make sure that we're listing the vertices in corresponding order. So side PQ is congruent to ST. Right? And if I call it side QR, it's congruent to TW. Okay, I can't call that side WT. Okay, notice the colors here. I'm listing them in corresponding vertex order. And then finally, side RP is congruent to side WS. Okay, now what if I had listed that last one as side PR? Well, that side would be congruent to SW. Okay, so it doesn't matter which order you list them in for the first triangle, right? As long as you list the second set in corresponding order. Okay, so I could have called this side down here PR, or could have called it RP. But if I call it PR, I better call this side SW. If I call it RP, I better call this side WS. Okay, and this is an example that has some algebra involved in it. So we are given that triangle TUR is congruent to triangle KEY. So just for the sake of illustration, I'm going to highlight my corresponding parts in color. So angle T corresponds to angle K. Angle U corresponds to angle E. And angle R corresponds to angle Y. Okay, find the value of X and the measure of angle K. Okay, well, since angle U is congruent to angle E, we could say that x squared plus 2x equals 80. And solve the quadratic. So this is x plus 10, x minus 8. So x can either be negative 10 or positive 8 in this case. Okay, so that's one part of the problem. The second part of the problem says find the measure of angle K. All right, well, angle K is this angle here, right, which we know is congruent to angle T. All right, well, what do we know about angles K and T? Well, we don't really know anything about them, but we do know that angle R, which is congruent to Y, has a measure of 30 degrees, 34 minutes, 16 seconds. Oh, you thought degrees, minutes, and seconds were going away, right? We also know that angle U and E have a measure of 80 degrees. Okay, so we know that the measures of all the measures of a triangle are 180. So that means that the measures of k plus y has to equal 100, right? Because look over here, we had 80 here. So together, these must equal 100. Okay, and since y and r are the same measure, I could really just substitute r for y anytime I see it, right? So the measure of angle K plus 30 degrees, 34 minutes, 16 seconds is equal to 100 degrees. Okay, and I'm just going to do that math over here. 100 degrees, that's 0 minutes, 0 seconds, minus 30 degrees, 34 minutes and 16 seconds, okay? Now remember, we can't take 16 seconds from no seconds, so we're going to actually have to go back and borrow. We're going to borrow a degree, and when we borrow 1 degree, we're adding 60 minutes, and we're going to have to borrow a minute, and to give us 60 seconds, and now we can do our subtraction. 60 minus 16 is 44 seconds. 59 minus 34 is 25 minutes. And 99 minus 30 is 69 degrees. So the measure of angle K is 69 degrees, 25 minutes, and 44 seconds. Okay, and I could actually extend this problem even a little further and say, let's say I tell you that, let's see, what if I tell you that UT, the measure of UT is 3y plus 2, and I tell you further that EK, again, naming them in corresponding parts, right? So if UT is 3y plus 2, and I tell you that EK is, let's say, 5y minus 10, and then my question is, what's the value of y? Okay, well, again, looking up here, UT and EK are corresponding sides. So because we know these triangles are congruent, we know that UT and EK must be equal to each other. Okay, so we could set these two expressions equal to each other. And solve. 12 is equal to 2y, so y is equal to 6. Okay, so the value of y is 6. I could have then further asked you for, well, what's the length of one of the sides? And you could substitute it in and find out that the side length is actually 20, right? UT is equal to EK, which is equal to 20. Okay, so that's another way we can use corresponding parts in a more algebraic-like problem. And we'll do more of those tomorrow in class.